So we'll move to the next section. Okay, now we're telling how to create the vacuum gripper, but we will just make it separated for 2 stages. Okay, so in the morning we'll just ask you to create a side interface and make it able to move with the robot. And in the afternoon, I will tell the behavior settings, okay, and some device settings in the afternoon. Okay, so first thing. Okay, we'll just click on this. Okay, these CAD features. Okay, so you can see when we just click on here, okay, here, there's no parent assembly. Okay, just one single feature. The name is robot tool. Right? And then you press, because you can see now the robot tool is under the full CAD file. We also need it to be a separate component. So now we click on right click. Okay, extract component again. Okay, I will separate this feature as a new component. Okay, extract component. Okay, and maybe you can just rename it really fast. Okay, you can just like double click, okay, and copy this name. Okay, and double click, okay, and paste this name. So you have a component. Okay, its name is robot tool. Okay, and you can see now also there's a problem. The origin of this robot tool is right here. So I recommend you to just do origin, snap again. Okay, maybe you can select the every point. It's fine. Maybe just select the point that is on this feature. It will be more easy for you to adjust the position of this component. Okay, like this. Okay, but if you doesn't relocate the origin, you can see if I just adjust the origin, it'll be difficult for you because I'm controlling here, but I'm looking here. It's not difficult for me to adjust this component position. So if you extract the component, okay, you can just use origin snap, okay, and select the feature on this component like this. So it will be more easy for you to change the position of it. Okay. And I think next step, okay, we can just like make it right here, okay, away from the robot, okay, away from the robot. Okay, make it right here. Okay, so please remember one thing, okay. If you select the single feature and this will be in yellow, okay. If you select this and it will be blue. So please make sure what node are you selecting, okay. The relationship is like in component tree, there will be a component node, right? And this one is mean the feature under this component node, okay. So for example, okay, like if I have a conveyor, this is a component node, right? And there will be no feature under this component node, but under this link space, okay, under this link node, there will be this yellow assembly under this link-based node. Like here you have track, right? If you select a track device, there will be this feature under this track node. Okay, so the relationship is that, okay, tree, okay, and component link, and under a link or device link, there will be feature, 3D feature. Okay, okay, back to here. Okay, if you want to quickly select this feature, you can also double click. Will be faster. Okay, single click is the feature. Double click will hover on the component or hover on the link. Like here, if I double click this belt, it will hover on. You can see now the belt will be in blue, so you hover on this track. If I single click the belt, it will just hover on this feature. Okay, that is the difference. Okay, okay, so you can just single click or double click. Okay, double click will be right here. You can see also right here, the property will not be the same. If I single click, means I want to edit some like color or some texture appearance of this feature will be single click. and it will be yellow. If I double click, it means I want to adjust the device settings. So you can see the bounding box, okay, the physics of it will be set for this track device. Okay, that is the difference. Okay, next step. Okay, we're almost done. So for this tool, I want you to build a start interface. We have mentioned yesterday, right? So we have to right click, okay, and create start interface. Okay, and please remember to switch the mode as child. Okay, and now when we create the start interface, now it's under detecting mode, so you can select any point to redefine the origin of it. Okay, so and then we need to make the X direction forward. Okay, like this, and then press down. Okay, I'll do it again. Okay, and also please wait a moment. I want to take a reference for it. Like what is the direction of it is we can use here to find start interface, right? So you can see now will be a start interface. Okay. If I hide anything, you can see there's nothing. If I show start interface, there will be an interface right here. So I do it again, okay, delete. Right click, create start interface. Select the point of the assembly point. Okay, maybe relocate or change the direction of it. Press down, oh here, sorry. Press, switch the hierarchy as a child. Because this component need to follow with the movement of the robot, so it will be child, and then press down. Okay, this one we already mentioned yesterday. Okay, so we can also take a reference, right? Like in our training model, I think we already have a robot. Okay, today we will not teaching how to build a robot. Actually, robot is already be built by our team members, so we don't need to build it yourself. Okay. Actually, you can use our model right here in our training, or you can also use in our modeling library. Okay. Here also will be a robot. You can find DRB70. Here is also another robot for you. Okay. You can just scroll here and release it, and here will be a robot. Okay. We'll just take a reference. Like here, okay. For a typical robot, okay, you can see here is at the endpoint of it. There will be also another start interface for you. Okay, you can see the X direction is front hand side and the Z direction is up hand side. So for the tool, X direction is front hand side, Z direction is up hand side. Okay, it will be with the same direction. Okay, I think we can just use the model that from our training, okay, day 2. Okay. You can also import this one, 04, okay, 04. Okay. And then for this robot, okay, you can delete it, okay, because we don't need this anymore. Because you can see from this one, actually we don't build anything. Okay, we will just delete it and replace by this already built model. Okay, and then we just assemble it on it. Okay, like here's the origin, right? So maybe we can just use snap, okay, and then select this point, okay, to replace this robot. Okay. Actually, right now we just need to focus on what is the endpoint directions of the start interface. Okay, so go to this model. Okay, please help me to create start interface. Then I'll do it again. Okay, create start interface. Select this point because this point is corresponding. There will be a pair, right? The flange have this point for assembly. So we also need to create a point for assembly at the full. Okay, and also we have to compare these directions. The X direction is front hand side, so we have to turn it 180 degrees like this. And then the hierarchy, please remember right here. Okay. you have to create a child side interface and then press down. Okay, I think you already know how to use. So if we import our example robot, okay, it's this one, 04. So after you build this side interface, you're already able to using our slot function, okay, to drag and drop to assemble the robot tool on the robot plane, right? And here's another thing, okay, if you want to slot the robot on this plate, okay, now it doesn't have anything for you, right? But the easier way is like this, okay, you can just use our snap function, because actually for this kind of cases, the robot base will not move and also the frame will not move. So you can also use snap. Okay, snap means the origin of this component will snap on the feature where you select, like this. Okay, so just select the feature you press, and then I can maybe just rotate 180 degrees. Okay, also check is this aligned with the hole. Yeah, it's aligned, so it will be done. Okay. So also, if you want to build your own stuff interface, it's also fine. So how can we do? Like here, we already know for the robot. Okay, we go to modeling and check with the robot. Here is the slot child, right? It's a child. It's a slot child. Okay. So if you want this child be assembled to here, okay, we can also like double click with this robot plate, okay, create slide interface and select this point, right? It's the same way. Okay, and then here's parent. Okay, make sure the orientation is same with the child. Okay, so that's rotated. It actually is the same way, but this is not necessary in this project. Okay, so parent, right, done. So when we just go to layout base slot, okay, you can see we can just also assemble it like this. Okay. So this is just the same thing you can do. Okay, so now we'll go on the modeling of this gripper. Okay, so also for modeling this gripper, okay, the first step, we need to click on this tool. Okay, actually it's not necessary, but it's recommend you to just add another link. Okay, so we can extract link first. Okay, just create a link base. Okay, but actually this is not necessary. So, but if you want, you can just build a link base. Okay, and next step, okay, under this link base, we will create a device, which is connector. Okay, so please help me to create the connector right here. Okay, right click, add device, connector. So after you click on add connector, okay, and then maybe you press apply. Okay, here's also another problem. Okay, the x-axis. Okay, the x-axis is also the direction of, right? X-axis is also the direction for vacuum gripping. Okay, so we also need to add device. Okay, and then select the connector. Okay, you can also select like x-axis like this. Okay. So that when you just select the feature, okay, minus x maybe. Okay, it will be like this way. Also you can just turn the direction right here. Okay, will be x-axis. Okay, so if you doesn't select the point while creating this device, you can also use origin. Okay, like move or snap to adjust it afterwards. It's also okay. Okay, I'll do it again. Okay, I just delete it. Right. So first, I just create an empty link. Okay, I'll do it really quick. Okay, delete. So I think it is the robot. Okay, so you can just create an empty link first. Okay, link base. Okay, and the origin doesn't matter. Okay, because we have to focus on the device origin. So next, I just right click add device, and then create a connector. And then I will select the endpoint, middle endpoint of this gripper. Okay, maybe like this. Okay, I can select this point. Okay, and then I will just change the direction of it, maybe make it X direction. Okay, change the property right here. Also, you can just drag it and then press apply. Okay, so how can we know what is the direction of for connector? You can also go to preference, okay, view. Here we also got the connector axis right here. So you can also enable this one. So you can see the red one is the force direction when you are taking the vacuum gripping. Okay, the X direction is the force direction. So you have to create this connector first. Okay. Okay, and next step. Okay, next step. Typically we'll need to create the behavior, right? But we'll find something that is weird. Okay, if you just create the vacuum gripper behavior, it's right here. Okay. Okay, you can tell me to create this first. Okay, create the vacuum gripper behavior. Okay, create this one. Okay. If you create a vacuum gripper behavior, you will find this is not possible to select this connector. Okay, that's because right down here we still need to have some settings. Okay, so you can follow with this step. Okay, here's the vacuum gripper. Okay, you can see, right click, we add the device, right? We add the connector. Okay, and we have already know the X direction is the detection direction. But second, okay, we have to change the physics and the device type right here. Okay, so here, okay, because connector, we also need to rely on the physics to pick up the top cover. So we need to enable the physics right here. Okay, and also under this connector, okay, right down here, we got the device setting. Okay, device setting right here. We have to make it active. Make it active. Okay. So there are two things you have to set. Okay. After create this connector, the first step, okay, enable the physics. Okay. The second step, okay, you have to enable the make the device setting active, so that when you go back to your behaviors, here you can select the connector. Okay. Okay. So next step. Okay. So I think you also know you need to set a digital input for it, right? So we also need to enable. Okay. Add another device, which is receiver, right? We need to get the control for enable the vacuum gripper or not. So we need to add a receiver. Okay. Press apply, and I think the name is right here. Receiver. Oh, here. REC top cover, but it doesn't matter. It just depends on what you want to name it. Okay. Okay. This is the receiver name. So back to our behavior, we also able to set the digital input right now, right here. Okay, and we still need something to work. Okay. Okay, this is quite important, because if you doesn't follow up this step, maybe you will fail for picking up. Okay, for the connector, if you turn on the physics, you also need to turn on the physics in his parent link. Okay, this link. You also need to turn on this one. Okay, this is a minion requirement for the connector, because when connector picking, you also need to translate to his parent link to enable this physics. Okay. So please remember to also turn on this physics. Okay. So, but like this, if your connector is right here, okay, I just do another example. Okay, if your connector is right here, okay, and you don't have this link base. Okay. Okay, if you build it like this, it's also fine. Okay. because actually link base is not necessary. It's not must in our vacuum grouper modeling. But you have to remember the connector physics and his parent link have to enable the physics. Okay, that is our design limitation. So, but if you just create a link, okay, like here, I just iterate link again. Okay, iterate link. Okay, maybe this is link base. Okay, I just recover it. But I have the connector and the receiver under this link, right? And also behavior. Right. So like this is one is yours, right? And then you have to remember, if you enable the physics, you also need to enable the physics of its parent link, which is link base. Okay, so right now, actually we're already done with the modeling of the robot pool. Okay, and maybe, oh, sorry, there'll be one more thing. I forgot, sorry. Right here we already done. Okay. And here, okay, we have to create the full frame container so that when we are using the robot to drop, to control, and there will be a frame for you to select. Okay. So next step, okay, next step. Right here, okay, at the behavior, okay, we have to select create full frame container. Okay, create full frame container. Okay, and then now you are under detecting, and you can just select the point that is you can select the point that is same with the connector, okay, like this. Okay, and then just press done. Okay, actually the direction is not really important. Okay. Okay, just select this point and then press down. Okay, just create a full-frame container. So now we already define like the X direction. Okay, it's the force direction, and also like typical. Okay, for this robot, if you're already familiar with robot, I think you also know the full-frame container. The direction maybe will be X with the front hand side and Z with the down hand side. Okay, but actually we'll help you to translate it. Translate the coordination. So even you set the full-frame container like this, it doesn't matter. Okay, you just need we just need a reference point for it. So we don't need to care about the orientation. Okay, so next step. I think we already finished with the full configuration. So we also can take a try for the pick and place process. Okay, so now please, and before that, I think we also need to do for the modeling of this top cover. So I think before testing, we also need a top cover for you to test. So we will now focus on building this top cover, okay? So I think we already import your robot, okay? If you haven't imported the robot, okay, please help me to import in today's file. Okay, it's right here. Okay, it's 04 robot something like this, okay? So I think you already know how to import the robot. So I will go on the top cover, okay, top cover. So also, if we need to pick up the top cover, we need to do something, okay? First, like we already create the connector for the gripper, but we also need to create a connector for the top cover, because for connector, if the for connector need to connect something, you have to be a pair, okay, a pair. Anti-connector need to take passive connector, so there will be two connectors, okay? So now back to our assembly, okay? You can see here. Okay, please help me just like, okay, modeling. Okay, select this one. Okay, the top cover, and right click. Okay, we also do extract component. Okay, extract component. Select and then help me to rename it. So we just expand it. Okay, double click, Control C, Control V. Okay, copy and paste. So there will be a top cover right here. Okay. And next step, maybe we can also adjust the origin. So you can press origin. Okay, please remember to select the top cover, not this one. Okay, it's this one. Top cover. Okay, origin, snap to adjust the origin right here. Okay, and then press apply. So now when you are trying to move the top cover component, you can find the origin is right here. Okay, so modeling, top cover. Okay, you have to go to your automatic machine to find top cover. Okay, extract component. So that there will be a new top cover component. Okay, so the first thing, okay, you just need to change the origin. Will be better. Okay, and next step. Then it is the same thing. We have to create a device. Okay, connector right here. Okay, so when you select the connector of the passive product, you also need to select the origin. Okay, the origin is right here. And also you have to make sure the direction is upward. Okay, like this. And then press apply. So you can see for the connector picking, there will be the force direction. Okay, for the gripper, the X will be downward. For the product, the X will be upward. It will be face to each other. Okay, force to force. So you have to create a connector like this. Okay. Okay, next step. Okay. So also in our connector, we also need to set some properties for the product, right? Like for our toolkit, toolhead, we have to set it active. But for product, we will have to set it passive. Okay, so the active connector will pick up the passive connector. Okay, so the type we have to set it passive. Okay, and also we have to enable the physics and also the parent link. Okay, the device link and its parent link, you need to enable the physics, make it true. Okay, here also make it true. Okay, and here the connector will be passive. Okay, so now maybe we can try start simulation and you will find something wrong. Okay, when we start simulation, you can see the top cover just for penetrate this magazine, right? So the question is, we also need to set the bounding box like here, right? We add a bounding box to make sure that the assembly will not penetrate the conveyor. So here is the same way. So how to create the bounding box? Okay, select the cover. Okay, and down here, okay, we will find the bounding object settings. Okay, you can press add. Okay, just select the cat feature. It will be top cover. Also, you can select right here, and then press done. Okay, and then preview. Okay, done. So that now you can see here's the box right here for you. Okay, but it doesn't work still. Okay, because you can see it also falling down because our magazine doesn't have bounding box. Okay, so we need two bounding box so that the magazine will support the top cover. Okay, so next step. Okay, we will also need to create the bounding box for this magazine. So you can just double click on this magazine to find out, wow, the feature is under this automated assembly machine. Okay, so we have to add bounding box under this component. Okay, so we just press add. Okay, and then we just find out the magazine feature. Okay, magazine is right here. Okay, so you can select the magazine feature and then press down. Okay, preview. So you can see here's a large box along with this magazine feature. Okay, you can select this magazine. Okay, and then press down. So that when we start simulation, you can see now the top cover will just support. Okay, the magazine will just support the top cover. Okay, maybe we'll stop right here And so please help me to, okay, the first step I will do it again, okay. Please remember to set the type to passive, enable the physics, and here, okay, enable the physics. And next step, okay, for the top cover, you have to create a bounding box, okay. Just right here, add. Okay, select the feature, press down. So that here will be a bounding box. And also with the magazine, okay, magazine is under this component. Okay, here's no bounding box, right? You just press add, okay, and then find out the magazine right here will be this feature, and then press down, so that it will be a box right here. So that when we start simulation, it won't fall down. And now the top cover is ready to be picked. Okay, so I think to this step you already catch up with the yesterday's progress, right? Yesterday we already asked you to do the robot teaching, right? And so to do pick and place. So we can go to program, okay, go to program. And then first thing, we also need to wire up the line for the robot. Okay, so we go to signal. Okay, signal. So find the robot and the robot tool. Okay, maybe we can try this. Okay, first we just wire up 102, okay, to this one. To the robot tool, pick top cover. Okay, please help me to wire this line up. So this one is like yesterday's process, right? Yesterday you remember this, so it will be actually the same. So I'll just do it wiring up. Okay, so actually like here we already write something. So maybe I'll take a try. Okay, here's some problem with the robot movement. Okay, that's okay, we can write it ourselves. Okay. So I just do it again, okay. I think yesterday we didn't know how to do, so I'll just operate myself. Okay, so after we are up and we already know the IO signal is port 102, right? So if we do it right, okay, so we also go to drop, okay, and then enable the drop by snap function. Okay, please, you can disable this orientation settings. Okay, and select the tool frame container under the slot parent. So that when you press right here, you can make your robot snap on this point. Okay, like this. So you can hit your robot point really fast by this way. Okay, so we'll select the point that you can see the connector and the connector will face each other. Okay, so also maybe here is the ready point, right? Okay, here's the picking point, okay, and then go back to the ready point again. And also I'll add a DO statement for picking the cover. Okay, the port is 102. And then I just press the initial pause to reset the posture. And now I start simulation. Okay, you can see now we are able to pick the product up. Okay, so maybe you can try it again. If you just catch up yesterday's process, I think you already know how to do it. Okay, I'll do it really fast again. Okay, so now we don't have anything. So how to teach point in our robot? Okay, first you have to select the robot. This is our component. Enable the drop mode. So now under the drop mode, I think default there will be TF0, right? You can just control the robot like this, okay? But if we build our tool frame container in the robot tool like this, okay, it just helps me to translate from this point to this point. So now the robot will know this point is the robot endpoint. So back to our program, if we just select the container right here, it will just help me to translate the tool tip from here to here. Yeah, but actually you can see the direction is not same with the default direction. But it doesn't matter because this is like a user tool frame. So our controller will help you to translate it back. So there will be no movement problem. Okay, so but with this, if you just select this, so now you can just hit the point right here. Okay, and then maybe change the directions. Okay, and then make a ready point, okay, teaching point, add a receiver, add a DO statement. The port is 102. Okay, and maybe we can use copy and paste. It's also fine. So there will be ready point, teaching point, and ready point again. Okay, so now we can select initial pose again. So if we try simulation, now they will go pick and place. Picking. Okay. So I think after pick, now we can try to place. Okay, we can try to place. Okay, but here we can see maybe we need to fix something for this placing, right? Like this bounding box. If you have this bounding box, maybe you have to delete one because another one is too high. So there will be collision. So for this product, sorry. Okay, maybe you can try one thing. Okay, go to modeling. Okay, here's the main assembly, right? Here's the main assembly. Okay, reset the simulation. I think we don't need this box for. We can only use the box of the plate. We don't need the box of the product, okay, because it's too high. So maybe we can just check out which one is the, okay, this one is the base, right? So this one, okay, the name is main housing. You can just delete it. So maybe this one, yeah. Okay, we only need for one box is enough. Okay, or maybe you have to adjust, like the height have to be same with the same height with this main housing. So that's a edit back again. Okay, so if we select main housing, it will be done, right? But you can see now the height is too high. So if we place our fixture on it, and then you will just put on the box right here. Okay, I'll do a quick try for you. Like here, okay, if I place our top cover right here, okay, like this. So what will happen? Okay, in the program, I would first not controlling the. I'll first keep the conveyor. Okay. So you can see when we start simulation, it will just fall on it, right? It will not, the cover and the housing will not have a right way to assemble to each other. Okay, so you have to also design the size of this main housing. Okay, the bounding box size of this main housing. So go to modeling. Okay, select the main assembly. Okay, so please help me to find out the box. Okay, and the select feature will be main housing. So maybe it's this one. Okay, this one, right? You have to change this bounding box settings. So I think the better way is if your dragger setting is 10. Okay, maybe I'll try with dragger setting 10. Okay. So maybe you have to make this box smaller. So X is the width, okay, Y is the length, Z is the height. So maybe I'll make the height shorter. Okay, maybe it will be 40. Okay, 45, 30. Too small, right? 35. Okay, maybe 35 is fine. Okay, so please help me to change the size of this main housing bounding box. Okay, so if I do it well, you can see after simulation. Okay, when we start simulation, you can see the housing and the top cover will have a better combination to each other. There will be no collision during the bounding box size. there will be no collision because of the bounding box size. Sorry. Okay. So let's go to main assembly. Okay. Find out the bounding box. The select feature is main housing. Change the height right here. So that will have a better size of this bounding box. So also go back to top cover. Okay, I'll just make it back. Okay, snap back right here. Snap. Okay, because the origin is not on the downward side, I will change the origin. Like this. Okay. Okay. Snap again. Okay, apply. So also I will try, is it above the peak? Yes, it's above the peak. Okay, and next, I will just do resume, continue programming. Okay. So let me think about it. So now I will keep on delete this statement. Okay, so now the conveyor will start. Okay, it will start, peak. Right, and you will just stop right here. So now I will ask you to teach the point for placing. So how can we teach the point for placing? I think yesterday we already mentioned. We have to create a capture position first. Okay, this capture position just record the layout relationship right here. Okay, so if we start simulation, then it stop, right? Okay, so I just pause and do another capture position. So when we just reset, okay, here's the first scene, okay, the second scene. So you can see now the product is right here. So I'm about to use this to teach the robot point. Okay, so back to our robot process. Okay, I just turn on the drop mode. Right, we're going to have this one is peak, right? Peak. Peak. Okay, so we also need to teach the placing points. Okay, so before we teach the placing point, we have to know where is the position we need to teach. Okay, so maybe we choose drop, right? Drop mode. Okay, please remember to enable the drop by state feature. Okay, and we can skip the set orientation. So if we select this feature, okay, and it will help me to, maybe this point is what I want, right? But we also need to consider of the seek of this top cover. So maybe there will be 18 higher. Okay, so we can switch to, we can just drag like this. Okay, maybe 20 is also okay. So this one is the placing point, right? Placing point. Okay, and here we also need a placing ready point, right? Ready point. Okay, so ready point, placing point. So I think we have to sort the order of it. Okay, ready point, placing point, and also copy, right? Paste. Ready point, placing point, ready point. Okay, and also we need another statement for release the gripper, right? So set DO statement. Okay, the port is also 102, and we'll disable the output value, make it false. So now after I teach a point down, you can just switch your capture back to position 1. So that will be the initial relation. Okay, please remember to switch it back. Okay, switch it back. So now, okay, when we start simulation again, okay, so this is place. Okay, place. So when we start simulation, we can take a try. Pick. Okay, you can see it released too fast, right? So in yesterday's training, we also do like a handshaking signal to each other. But I think right now we can skip this, okay? Because today's modeling training, I think we can just make some delay. So maybe pick, okay, and wait for 5 seconds to make sure the product is arrived at this position. Okay, place. And you can see maybe there's moving too fast. So I will check again, okay? Pick. Okay, you can see it just fall down. So if it is falling down, maybe we have to change some property of this gripper. So in my opinion, I recommend you to make the force a little bit stronger, like this. Okay, maybe there will be a 10 kg force to pick this top cover. So that it is about to pick. Okay. So I think we will stop to this status. Okay, because yesterday we already finished the whole process, and I think you already have an ability to finish the rest. Okay, so we'll just stay right here. Okay, you can see pick. Okay, and come here and place. Okay, and also if you want to write something else, maybe you can just keep writing with the PLC process, right? Like here you got write AC. Okay, so maybe we can also wait for about 5 more seconds and finish the rest, right? Like here maybe will be for AC. Okay, AC down. Okay, I think will be better. Okay, it will be false, right? And you will start the conveyor again. Like this. So maybe we can take it. Okay. So now you can finish the whole process. Okay, please take a try.